Hello everyone, in this video we are creating our RAG system, Retrieval Augmented Generation system. Just a quick introduction on RAG system. So as you can see, our RAG system basically takes some text data in our data set and using an embedding model, it turns those text information into numerical representations we call numerical embeddings. On the other hand, we do the same thing to our query. We have a query here, and using an embedding model, we turn the query into numerical representations. Now we have two numerical representations, one for our query and one for our text data set. And what we need to do is use a similarity search function, which is provided by our vector database to find articles that have similar numerical embeddings to our query, which helps us find the article that match our query. So let's have a look at our code. So as you can see, the first thing we do is installing the required libraries, and I'm going to explain why we need these libraries later in the code, and we import our dependencies as well. And here we have our first class, and here we have our second class, and we only have two classes in this code, which are the two main parts of the code. So going back to our first class, we have the AI agent class, which basically contains our large language model, which is GIMA, provided by Google, and it takes a user query and the context provided by the RAG system to create a response based on the context the RAG system provides it with. So this is our AI agent class, and we also have our RAG system class, and the RAG system is responsible for retrieving the relevant information from our data set based on the query we received. So we can use whatever type of data set we want, but in our code I'm using a PDF file which is about OmniThink. This is a machine learning research PDF file, and this class finds the relevant information based on the query, and it passes them down to the AI agent class. So the first thing we need to do in our AI agent class is importing our model. So our model is actually GIMA 2, and we import the model, and the next thing we need to do is to create a prompt. As you can see, a portion of our prompt is already provided, and we actually have some placeholders for query and context. So query and context are information provided by our RAG system, and using these information we create our prompt, which will be later passed to the generate function to generate our response. Now in our generate function, we first of all call our create prompt function, and we pass the query and retrieved info to the function, and it gives us the prompt. So we use the prompt here to create input IDs, and input IDs are basically the tokenized version of our prompt. So they are the tokenized version of our prompt, which our model can understand because they are in numbers. So we have our input IDs, and we put them inside our generate method, and we define our max new tokens, and it gives us our answer. So we have our answer, and we decode this answer to have a text response rather than a numerical response. And the last thing this class does is returning the prompt as well as the answer. So let's actually check the class we just created. Here I just typed into the cell a context, and I just provided a query as well. What does OmniThink do? And this context basically explains what does omnithink do. So it gets the context, prints the context, and here we print the LLM answer. So as you can see, the LLM answer is basically based on the context we provided the machine learning model with. And that's what we are trying to do with our RAG system. But for our RAG system, this context is provided by the system itself, and we are not typing the thing down into the cell. The model just retrieves the information based on the user query. So in order to do that, let's have a look at our RAG system. And as you can see, the first thing we do with our RAG system is importing our PDF file. So I have a PDF file which is a research regarding omnithink, and I just provide the PDF file, and using PyPDF loader I load the PDF, and I get the documents, and I save them as documents. So the next thing we need to do is to split our text based on certain chunk size and overlap size. So basically, when we are retrieving our information, we need to split our text, right? Because we have a big PDF file, and the model can't just go through all of these PDF files. It needs to go to chunks of data, and our task is to find out what size of chunk is good enough for our model to find meaningful information. If it's too big, then the retrieved context is not gonna be as useful, and if the chunks are too short, we might not even get a response with enough context. So we need to play around with numbers, but what I have here works very well with my PDF file, and you can try with this number first. And here we just split our documents using the text splitter we created here, and here we need to import our embedding model. As you remember, I mentioned our embedding model is responsible for turning our text data set into numerical representations. So for this task, we are using Almini LM L6 V2, which is an embedding model, and it's a good one, and it works with many other languages. So here we are also defining our vector database. So basically, when we split our data set into different portions, we need to store these portions somewhere that can be accessed later by our query. And in order to do that, we are using something called Chroma. And you don't need to sign up for anything to access Chroma. It's provided for free, and you can just type it into the text, and we already installed the required library and dependencies to use Chroma. So we basically pass our embeddings into Chroma, and this handles the storage of our and of our embeddings. So here we define our retrieve method, which basically gets the query and finds the relevant documents. So as you can see here, we get our user query, and we put that query into the retrieve function, and the retrieve function returns the relevant documents, and the relevant documents are basically turned into a string, and their page content is actually extracted as strings. So now we have our basically we have our data, which is our retrieved data, which is our context, and we pass the data and the query into the generate function, the AI agent.generate function. And as you remember from the previous part of the code, it returns prompt and the answer. So we get the prompt and we get the answer, and here we are basically putting our question answer and context into a template which we defined here. It's not really important. I mean, it's important for the design purpose and making sure the thing is readable, but it doesn't play a part in the model itself. So we we format our uh, question, answer, and context, and now we can actually test the rack system. So if you come here, I have already done that. So how does OmniThink work? How does OmniThink work? And this is my query, and as you can see, the rack system goes through the PDF file and finds the relevant information on how the OmniThink works. So the response to our question is actually here. Expansion. OmniThink expands its understanding of the topic by retrieving information from the search engines and 2 and 3. So it provides us with some bullet points. And if I go back to our code, I can actually show you the PDF file. So this is the PDF file I used to instruct uh, sort of this rack system, and as you can see, this is a research dates. This is a research article, and if we go back, we can actually see that many of the bullet points mentioned by the rack system are mentioned in here too. Information acquisition, and initialization, reflection, expansion. So basically, the rack system retrieved this information from the PDF file and it passed them to the model. So the model can generate this information based on relevant information. So that's it. That's how our rack system works, and I can just scroll through the code one last time. We installed our libraries, we installed our dependencies. This is our AI agent class, which basically generates the response based on the query and the context passed down by the rack system. And here we just tested the rack system. So thank you very much for watching this video. Please don't forget to like and subscribe, and if you want me to create a video on a specific topic, please leave them in the comment section. Thank you very much and have a great day.